Welcome to the Explainer. Today, we're taking a dense Google Cloud study guide and transforming it into your practical, easy-to-understand architect's toolkit. Let's be real. If you've ever felt overwhelmed by the sheer number of options in the cloud, from basic web apps all the way up to massive, globally distributed systems, we are cutting through that noise right now.
Before we jump into the weeds of infrastructure, we have to ask the ultimate question that every single cloud engineer faces when looking at this massive ecosystem: VMs, Kubernetes, serverless. How do you actually know which tool to pick? Well, the secret isn't about memorizing every single detail of every product. It's about understanding the spectrum of control versus convenience.
So here's our game plan today. We'll start with 1, welcome to the cloud, then explore 2, the compute spectrum, tackle 3, storing and organizing data, lock things down with 4, networking and security, and wrap up with 5, tools, analytics, and AI. All right, let's get into it.
Welcome to the cloud. Let's kick things off by looking at the foundational shift in how organizations actually handle their IT resources.
Now, you hear public cloud computing all the time, right? It sounds a bit like a buzzword. But to truly leverage these tools, we first need to define what makes the public cloud fundamentally different from traditional IT. It's the core concept that dictates literally everything else we're going to talk about today.
Think about it like this. With traditional on-premises setups, you're the one sweating over physical hardware, power, cooling, the whole shebang. Even if it's in a third-party co-location facility, it's totally on you. But with the public cloud, providers like Google take over all that physical burden. You're happily trading the headache of racking servers and managing tangled cables for the pure agility of managed services. It's a real game changer.
And this brings us to serverless. Now, quick reality check here. Serverless doesn't mean servers just magically vanished into thin air. There's always physical hardware humming away somewhere. Serverless simply means you do not need to configure, monitor, or maintain those underlying resources. Google handles the grunt work so you can focus strictly on developing your code. Pretty sweet, right?
Okay, moving right along to Section 2, the compute spectrum. Now that we're anchored in what the cloud actually is, let's look at the engines running your apps.
I love looking at it this way because your choices sit perfectly on a spectrum. Up at the very top, for absolute maximum control, is Compute Engine, Google's virtual machines. You choose the CPUs, memory, operating systems, you can even attach GPUs. Slide down a bit, and Kubernetes Engine gives you medium control for orchestrating groups of containers. Then, boom, we hit maximum convenience with our serverless options. App Engine gives you language-specific sandboxes, and Cloud Run lets you fire up stateless containers without ever touching a cluster.
So let's put this to the test with a real-world scenario from the guide. Say you've got this algorithm spotting cancerous cells in medical images. It's a heavy-duty, computationally intensive app doing tons of floating-point math. It needs instant access to huge amounts of data, and here's the kicker: it cannot be easily distributed across multiple servers. What do?
Well, since you can't just chop the work up across a cluster, you need the massive raw horsepower of a single server. You absolutely need a Compute Engine VM for this. Those floating point calculations, they're screaming for a GPU. The intense workload needs high CPU, and that instant data access means you need a high memory configuration. This is exactly where high control isn't just nice to have, it's a strict requirement.
All right, let's completely flip the script. Imagine you don't need a massive beast of a machine. What if you literally just have a tiny snippet of code that only needs to execute when someone uploads a file or when a message hits a queue? How do you handle that without managing servers?
That is where Cloud Function shines. It's your immediate go-to. It is 100% serverless, requiring absolutely zero configuration from you. You just write your code in something like Node.js or Python, and Google only fires it up when that specific event triggers it. And the best part? You only pay for the exact milliseconds your code is actually running.
That brings us to Section 3, storing and organizing data. Because let's face it, all that compute power is totally useless without data to process. We really need to draw a hard line between these two types of storage. First, you have object storage, which is cloud storage in the Google world. This is for unique files you'd grab with a URL, like images or backups. It scales forever, and this is a big but, it is not for databases. On the flip side, you have file storage, like Google's File Store. This uses standard NFS, so if your legacy apps are demanding traditional block-based access neatly filed into directories, this is what you want to reach for.
And when it comes to databases, it's all about one fundamental trade-off. Relational databases like Cloud SQL or the globally scalable Cloud Spanner are your go-to for strict, flawless transactions using standard SQL.
But if your app demands massive, unbridled horizontal scale and super fast queries, you pivot to NoSQL options like Firestore or Bigtable. Basically, with NoSQL, you're trading away a little bit of that strict consistency to get absolutely massive scale.
Let's ground this with an awesome example. Imagine you've got 100,000 IoT sensors spread across a bunch of factories, and they are blasting data at you every 5 seconds, nonstop. You just need to catch all that data and run daily, min, max, and average reports. No complex transactions needed here at all. How do you catch that fire hose?
If you tried to pipe that into a traditional relational database like PostgreSQL or MySQL, it would absolutely choke. It just can't handle that kind of relentless read and write speed. But Cloud Bigtable, it thrives on it. It's a wide-column NoSQL database specifically built to swallow billions of rows of high-speed data effortlessly, which is exactly what a massive IoT fleet requires.
Moving into Section 4, Networking and Security. We've got our compute, we've got our storage, now we have to connect it all together and lock it down.
Think of these 4 tools as your digital fortress. When internet traffic comes knocking, Cloud Load Balancing is your front door, smoothly routing requests across the globe. Right next to it is Cloud Armor. That's your bouncer, blocking DDoS attacks and SQL injections right at the edge. Once inside, your virtual private cloud, or VPC, keeps everything isolated and secure on Google's private network. And rounding it out is IAM. This is your VIP list, making sure only authorized users or automated service accounts actually have the keys to touch your stuff.
And finally, Section 5, Tools, Analytics, and AI. Let's talk about how to manage all this infrastructure and actually get some value out of the data you've carefully stored.
There's a really clear life cycle to understand here. When you're building, you're practically living in the Cloud SDK command line, setting up your VMs and firewalls. But the second your app goes live, you turn into a detective. If a product manager says an app is crashing, you don't just guess what's wrong. You pull up Cloud Monitoring to check the vitals, you dive into Cloud Logging to see the raw events, and you check error reporting to see exactly where the code blew up. It's basically your ultimate operational survival kit.
Okay, one last scenario for you, and it's a super common one. Say your data scientists need to run a specific machine learning library that only exists in Apache Spark. But, they're data scientists, not system admins. They want to do their math with zero DevOps headaches. How do you give them what they want?
Well, you definitely don't want to be manually building and babysitting a Spark cluster on a bunch of VMs. Instead, you just wave a magic wand with Cloud Dataproc. It spins up a fully managed Hadoop and Spark environment instantly. Your scientists get the exact tools they need, and you don't get stuck with the administrative nightmare. Win-win.
Wow, we have covered a massive amount of ground today. From the absolute granular control of virtual machines all the way to the magic of serverless, and from strict SQL to globally scalable NoSQL databases. You've got the toolkit now, and you understand the exact trade-offs. So, with the entire power of the cloud at your fingertips, what incredible architecture are you going to build next?